In this lesson, we're going to go over inverse trigonometric functions. So if you remember from sine, cosine, and tangent, we use those to find missing sides when we have an angle and a side. We use inverse trigonometric functions to find the angle. So let's look at an example. We have a triangle, and we're given two sides. We'll just say x and y. And we'll have to find out this angle theta. Well, first let's set it up just using regular trig functions. So we have so, ka, toa. We have an angle, the opposite side, and the hypotenuse. And we end up with sine theta equals opposite over hypotenuse. So we have sine of theta equals x over y. Okay, but if these were given, say for example, the opposite side here is 5 and this is 10, then we have sine of theta equals 5 over 10. And we want to find out what theta is. Well, let me first start off by saying that most students, when they get confused, what they try to do is divide by sine. But we can't do that because it's not sine times theta, it's sine of theta. So we can't divide by sine. Instead, to get theta by itself, we do the inverse of sine. So we end up doing the inverse of sine to both sides. We end up with theta equals the inverse sine of 5 over 10. And just so you know, inverse sine, you could also say this as arc sine. These are both the same thing. Arc sine, inverse sine, same meaning. So if you put this into your calculator, you'll find that theta equals 30. So again, if we're looking for the angle, we're going to eventually have to do the inverse of sine, cosine, or tangent. But we could start off by setting it up with our regular formula. And this would be true for any combination. It doesn't have to be sine. So erase this quickly. I'm editing this out. This is taking forever. So instead, if they didn't give us the opposite side, if they gave us that this side is 5 radical 3, well, first of all, this is the adjacent side. So we're still looking for the angle theta. Okay, we don't care about the opposite anymore. We have the adjacent side and the hypotenuse, so we should use cosine. So cosine of theta equals adjacent. over hypotenuse. So cosine theta equals 5 radical 3 over 10. And again, we can't divide by cosine, so we have to do arc cosine of both sides, or inverse cosine, and we end up with theta equals the inverse cosine of 5 radical 3 over 10. And if you use your calculator, we'll get that theta again equals 30. Okay, now let's look at one more time. We'll do it with inverse of tan. So maybe they didn't give us over here that this side is 10. Maybe they gave us that this side is 5. Again, this is the opposite side is it's across from theta. So we have opposite and adjacent. We have to use tangent because tan of theta equals opposite over adjacent. So we have tan theta equals opposite over adjacent. So we have tan theta equals 5 over 5 radical 3. And now to get theta by itself, we have to do the inverse tangent of both sides, or arctangent. So we end up with theta equals arctan, or inverse tan, 5 over 5 radical 3. If you're using a calculator, make sure you put this as parentheses divided by this in parentheses. And we'll still end up with theta equals 30 degrees. So again, if we have two sides and we're missing the angle, we can easily just set up our sine, cosine, or tangent function like normal. And then to solve for theta, we have to do the inverse of that trigonometric function.